Hi, I'm Olivia, and welcome to Engineering in Real Life, where I explore the real-world design process to inspire the next generation of engineers through shared experiences and guidance. Today, I'm interviewing computer engineer David Lindley, former program manager and integrated circuit designer. He has worked at various companies such as Cypress Semiconductor Corporation and a few startups, and we'll discuss his work in computer engineering and chip design. Hi, Mr. Lindley. Thank you for joining this interview today. Can you start off with introducing yourself, about your different companies you've worked at and the roles you've had in them?
Sure. So I'm David Lindley, and I have been working in the industry now since 1988. I have worked for several companies. So I started out working for the Defense Department for a year, and then I worked for what we call a design house, a company that just designed chips for other people. They didn't have any revenue stream other than doing design work. And in there, I was just a junior engineer, basically designing circuits and laying out chips. From there, I went to Cypress Semiconductor, where I stayed there for a little over 14 years, and did everything there from just junior engineer doing layout and just circuit design. And from there, I moved into program management, where I was leading chips and then leading intellectual property. The company moved from groups doing whole chips to groups doing a bunch of different types of IP, specializing in different circuits. And from there, I went to a company called Camgen, which was a startup, just doing lots of different, not chips there, actually doing boxes, electronic assemblies. Then from there, back to Cypress for 5 years in a different location, still doing program management, both managing chips at that time and also then moving back in IP. From there, I went to a electronic assembly doing military SATCOM systems, managing those. I was in charge of mudbox modems, which are satellite modems that they call them mud boxes because they would throw them in the mud behind the terminal out in the field. We sold them to the military. So I worked there for 3 years, and then back to Cypress again but by that time they'd been purchased by a company called Infineon. And I worked doing the same job I did in Colorado, but I was in Kentucky. And then from there, I went to eFabless for a year, working for your dad. And then since eFabless went under, I've been doing contract jobs, working with Chip Foundry and also working with Infineon also, again. So I can't seem to get away from those guys, I guess. So I don't really know the count of that. Cypress was in there 3 times, I know, if not 4 if you count them now. And then I've done everything from program management of chips to electronic assemblies. I've laid out chips. I've designed circuits on chips. I've laid out PCB. I've done PCB design and wrote a lot of code in there too. So it's been a long and varied career to this point.
Wow, that's a really interesting story about your career. I'm excited to get into it. You did a lot of chip design, and then you did project management. So yeah, It's really interesting. And then the satellite, with the things when you're mentioning the satellite, would sound really cool too. It's a variety of different experiences.
I've enjoyed it. It's been real fun.
Yeah. Okay, let's move on to the first question. Why did you become an engineer in this discipline in chip design?
So when I was young, I was always considered kind of a nerdy boy. I like to read. I read science fiction. I took all the maths. I always knew I was going to go to college and go into a field, some sort of either engineering or technology field. My father was a programmer, and this was back before anybody had computers. This was back in the 70s. And one time when I was very young, he brought home basically with a typewriter where he called into the computer, a mainframe computer, and he would type and then the computer would type back. It was basically a terminal without a screen. That's how long ago it was. And so I always knew I was going to go into technology. I like computers. I had one of the early computers I bought. We got one from TI, And this is again, I went to high school that had no computers. So how long ago it was? We didn't have personal computers. There were no PCs, no laptops, nothing like that. And I wanted to know how to build a computer. But for some reason, I decided I was going to go into chemical engineering until I went to the university I was going to go to for discovery between between I graduated and before I started college. And I walked into the chemical engineering building and looked up and I thought, nah, I don't want to do this. These are pipes. I don't want to do pipes. And so I started. I was one of the first students at Mississippi State University, where I went to school, that started at computer engineering. It was a brand new curriculum at the time. It went from freshman to graduation in computer engineering. That was one of the first classes that did that whole curriculum. And it was basically a mixture of electrical engineering and programming. But so anyway, so I've always wanted to be technical, and so I went to become a computer engineer. And at that time, I was probably going to become a firmware programmer until my next to last semester. I took a special topics class on computer-aided design, and I really enjoyed writing tools, writing code, and doing stuff with circuits, computer-aided design. And then when I finished that class, a friend of mine told me, well, there's a class you can take that they use a really neat CAD program called Magic, and you get to use CAD tools. And so it's VLSI. I had no idea what VLSI meant, very large scale integration. And so I took this class and fell in love with chip design, chips. And it was my last semester, and I changed my whole plan from going to becoming a firmware programmer to becoming a chip designer. And so that's how come I ended up. It was just a fluke. I ended up being in chip design because a friend of mine told me that it had a neat program you could go use when you took the class. And from that, I decided to be a chip designer.
Wow. So you really didn't go into it knowing what you were going to do at the end. It was kind of like something a little bit unexpected.
It was. I was planning on being a firmware programmer. In fact, all the jobs that I interviewed for were programming jobs. And then I ended up taking this class. My next to last class was on CAD, computer-aided design, and how to writing code, writing scripts and stuff. And I liked it so well that a friend of mine told me to try this other class on basically chip design that I had no idea it was there. Didn't know anything about the class. I jumped right into it. It was one of the hardest classes I took. I think I made a 25 on my first test. That was scaled to 103. It was the professor was an extremely intelligent fella, and he would give us a book. Every test was a book, and basically you just figured out which problem you could solve, you could answer, and then he would scale it. And it was extremely difficult class. In fact, went back and sat through it one time again later on, just to kind of gather information. I didn't take the class, but I was working right off campus, and so we just walk up there and sit in the class, and he didn't care. He didn't care if we were there or not. But it was just I fell in love with sitting in front of a big computer monitor with all the colors and doing layout, which is just part of the implementation of taking a circuit and putting it into the physical realm on a chip.
Wow, that's really inspiring how you trying something new led you down a path that you finally love and appreciate. You really overcame a lot of challenges of going through that hard class. That's really inspiring, trying out new things and being open-minded. So would you say that's a good skill to have as an engineer, being
absolutely.
Really
Absolutely. You have to be open-minded because being an engineer is nothing but solving problems. And you have to enjoy solving problems and not be discouraged when you're trying to solve a problem. Because if you're an engineer, you run into, you have problems, you face problems that you just can't say, I'm not going to do it. I'm not going to solve it. It's too hard, because it's your job to solve that problem, and you have to do what you can to solve it. And I have faced several difficult problems in my career, and you just can't give up. It might take a long time. It took us 3 chips. My hardest problem I've ever faced, it took 3 chip designs before we finally got it right, fix the problem. And you just have to keep plugging at it until you get it done. But yeah, open-mindedness and looking at things from many different angles is basically what an engineer does.
That's really helpful for me because I feel like I struggle getting out of my comfort zone. So that was like really helpful advice. It also leads into my next question of, what do you find most challenging in your career?
Work-life balance. Okay. Being an engineer, being so wanting to, to face challenges, to solve problems, and to complete chips, or complete work. I don't want to say chips, complete work. I and a lot of people I've worked with, we spend a lot of time working and not at home, and not with our families. And it's hard. It was hard when I was young, because it was expected at the same time to work extra hours to stay on schedule. And so, for me personally, the hardest thing I've done, the worst job I did of it too, was trying to balance work versus life. I said, when my kids were little, I spent a lot of time going, at work, late nights, weekends. It just wasn't fair to them, and wasn't fair to my wife. And that was the hardest thing I did, was trying to balance that, and I didn't do a very good job of it.
Wow, that's really interesting. I feel like I relate to that with like my dad as well. I think he also had that same problem too.
Yeah. I saw some of his messages came across a little while ago, so I know he's working not too long ago. So yeah.
On the other hand, what do you find most rewarding in your career?
Well, we talked about solving a big problem is a great thing. It just makes you feel wonderful. And so that's something that, like I said, we face problems all the time and solve them, and that's just fun. But I think the most rewarding thing I've done is mentoring, working with young engineers and basically helping them learn the job and bringing them along. I really enjoy going. When I worked at Cypress, for one, I recruited, and I would go to my school was Louisiana State University, LSU in Baton Rouge, and I really enjoyed talking to kids and showing them what I did and getting them fired up to come to my company and work for us, and then getting them there and helping them, train them, because you come out of school, you should know the basics, right? But you're not going to know the how-tos, really. Like here's how you do it. Once you know what a chip, you know what a circuit is, but here's how it all goes together. And so I really like that part of working with. And that's one thing I liked about being a program manager before that, being a senior technical guy, is we had young people that, young engineers that we would mentor and, bring them along. And I always enjoyed that the most.
Wow, yeah. That's like more on like the application aspect of like what you learn,
Yeah. So, when we would interview somebody, go hire somebody, we would look at the classes they took and see if they learned that, and in fact, at one point in time, I only had 30 minutes. When I went to Baton Rouge to interview, I only had 30 minutes to talk to interview a candidate. And I'd go there the night before, and we'd have a pizza night, and I told them all, talk about the company and all about that. And I'm telling them, I said, tomorrow morning when you come into my room, I want to ask you, what's your favorite subject? I'm going to give you a question. And, we don't have, we're not doing all the chit chat tonight. Tomorrow, we're going to be real focused. And I would have all these problems like software, circuits, logic, all these different types of problems. And I have them all copied. I had like a stack of them. And they come in and sit down. I say, what's your favorite subject? And they tell me, here's your problem. And so, when we would hire a new college graduate, all we wanted them to do was know what they had studied. We didn't expect them to know how to put a chip together. We just know, if they said they knew how to do logic design, we expected them to know how to do logic design, and you would ask questions about that. And then, like I said, when they started work, then you would, teach them how to design the chips and put the chips together and all that stuff. And then that's one reason why a master's student comes in, someone comes in and has a better salary at the beginning, because they have had a couple years of doing this already in their master's program. But mentoring was always very satisfying to me, to help some young guy or gal, come in and become successful.
Yeah, that's interesting. Moving on to the next question, what was your favorite project as an engineer?
So I didn't really have a favorite project. I had a favorite type of project. I really liked doing a full chip design development. And so when I first started at Cypress, I worked on a thing called a certain type of chip called a dual port SRAM. It was a memory chip, and it had basically two ports. You could have different processes on either port, sharing the memory. It was used kind of a buffer, like at the time that telecom. If you had a cell tower talking real fast to a bunch of different cell phone conversations, and then you use it, you'd fill it up you'd store data to this, and then the LAN side would take it out the other side at a different speed. But I enjoyed doing those, and that's where I started. I started at Cypress doing doing circuit design pieces, and moved up to where I was in charge of the full chip. Those were my favorite of all the chips that I did. Those were my favorite to do. And of course, they don't make them anymore, because nobody really has memories like that, discrete memories like that anymore.
I was just wondering if you could tell me more about like the chip design with the ports. Like, could you explain it a little bit more, please?
Sure. So SRAM is static random access memory. It means it is a RAM. RAM is storage, and random means you can store anywhere you want to store. And so normally lots of companies make SRAM that are single port, and you put them into your like say if you have a single port chip, you put it on your board and you would store data there. You do a bunch of calculations, you put data there, and then later on you come back and get it for something else. A dual port is still a static random access memory, SRAM, but it has two access ports into it, and it's usually used as a buffer. At the time, it was used as a buffer, so you could have one side, the process on one side operating much faster than the process on the other side, and so you have the real fast process fill the chip up, and then the real slow process will slowly take it out. That's one way to use it. It was used in a lot of telecom applications, and so they were big chips, very costly to make it, but they weren't a real huge seller, but we could sell them for like $100 a piece. So there's only two companies making them for a long time, and the first company to come out with a new chip made a lot of money, real quick. And then the other company would come out and make the same chip, and the prices would fall.
Yeah, I think that makes sense. Like I took like an introduction to computer science class, and I feel like what you said kind of aligns like with the same things I've learned there, like with the RAM. I've like heard of that term before.
Yeah.
In some of the projects that you've worked on, was there an example of a hard problem you faced, and how did you solve it?
So solving it, so the problem that we faced was the first dual port that I designed with, I worked on the Cypress Semiconductor. It was a new, the chips that the dual ports they designed were all very similar. But the deal was, though, you moved to a new process node that was smaller technology, and you can make a bigger chip, or bigger, make more bits in your SRAM without growing the chip. And so this was a new technology node for dual ports, and we designed the chip, and it worked good, but it had a glitch on the output. And so the way it was supposed to work was you put your addresses, what memory location you wanted to address, and then you would toggle and enable. And 15 nanoseconds later, the data would come out on the output port, and the data would start to come out, like the outputs would start to go high, and then they would go low. It was a glitch. It would glitch low, and then it would come back high to where it was supposed to go. And this glitch caused the data to come out at 18 nanoseconds instead of 15 nanoseconds like it was supposed to. So we couldn't sell it as a prime end part, the most expensive part. We had to sell it for something much slower. Plus, it's really a bad design for your outputs to be toggled like that. And so we worked on that. The whole team worked on that. The team being several designers, test engineer, and the project leader, which wasn't me at that time. And we did a whole bunch of different experiments, and we finally decided that we had reached, basically we had all of our best known fixes, and so we did it. We decided instead of doing another tape out of this chip, we did what we call a chop instead. So this was an 8K by 36 bits. So it's 8,000 words by 36 bits in each word. That was the size of this RAM. But on the product line, they were going to make a half size chop it in half, so it would be 4K by 36. And they did that to save money, because the smaller the chip, the more you could put onto a whiteboard. And so we decided to take all of our best guesses. We got all the learning you had done, all the experimentation, and do the chop. And so we did the chop, and I actually was able to optimize some parts of the circuit in the layout. And when we get it back, got the chip back, it still had the glitch, but it was better. It was much better. Still the glitch though. And so we're looking at it, and we're trying to figure out what had happened that made it better without fixing it. And then we finally, the test guy noticed something, that a pattern in the output waveforms. When you run, you put the chip onto a tester, and you can run patterns at it, and input patterns, and watch the output patterns, and you have expected output versus what you really get. And so he was testing it, and he noticed that the glitch only happened at certain times. And based on that, we were able to go back and identify the circuit that was bad and fix it. And then we retaped out the half chip, and it worked just fine. And then we unfolded it to make the 8K part, taped it back out. This was over several years. Solve this problem took years, and a lot of effort and a lot of cost too, to get this problem solved. And it was, like I say, it was a team effort. It was me. It was a whole team effort to understand the problem and fix it. And we found, like I said, it took 3 tape outs, 2 chip designs, and 3 tape outs to get it to really work. And it was a difficult. In fact, we had a saying once we had is ding dong, the glitch is dead. Once we finished the finally got it fixed.
Wow. That sounds like a really like tedious process, but I'm sure at the end of it you were like it was really rewarding for you, like you
Yeah.
said. With
Well, I had long hair back then, and I was pulling my hair out trying to figure out what was going on.
That's funny. My final question is, if you were to go back in time to when you first started, what piece of advice would you give yourself?
So I made a conscious decision after about 10 years in the field to go into program management. Up until that time, I did a lot of coding, not writing programs for like as a job, but writing programs to help me do my job. And so I went from, being a team member to one of the team leaders to being a program manager. And when I went into the program management side of things, I had to let those programming and just doing technical work kind of go by the wayside. Now, looking back in hindsight, maybe I didn't need to let so much of the technical work go like I did, but I did. And so if I could go back and talk to myself then, I would tell myself, stay on the technical ladder. Don't go into program management. I say, I went into program management because I really enjoyed talking to the business unit people. I got really grooved on watching, the sales numbers come in and think, oh, look, my chip that I designed made the company $4 million this quarter. And so, I went off in that way. But if I go back and talk to myself, I would tell myself to stay technical. Don't go do program management stuff. Just stay as a technical resource.
Thank you so much for your time, and I really appreciate your responses. They're really valuable. And
You're very welcome.
of course, yeah. Thank you so much.
One of my biggest takeaways talking with Mr. Lindley is that engineering requires flexibility and spontaneity. He originally went to college for chemical engineering but transferred to pursue computer engineering, a brand new degree at the time. His story shows the importance of an open mind in engineering. You shouldn't be confined by what everyone else is doing, but instead should test the limits of technology. Today, this can apply to growing industries like AI, CRISPR, and space tech. Within his new major today, Mr. Lindley was not sure of what he wanted to do. He initially planned to go into firmware programming until his last semester when he took a computer design class on a friend's recommendation. Even though he had no prior knowledge and got a 25 on his first test, he persevered in the class and eventually followed his passion in chip design. As someone who's naturally indecisive, his journey reassured me that early career decisions are not yet set in stone and there is always room to explore. I also learned the importance of not giving up. Often I confuse what I enjoy with what I'm good at, but I am reminded that there will be many times in engineering where you don't know anything and you have to get out of your comfort zone, like when Mr. Lindley took that really rigorous computer modeling class. Overall, I learned that results take a lot of effort and failure. For example, it took Mr. Lindley 3 completely different chip designs before he got the results he wanted. Ultimately, his experience taught me that engineering requires flexibility, both in finding your passion and in problem solving. All in all, growth comes from trying new things, stepping outside your comfort zone, and not giving up.